Hey everyone, how's it going? Daniel here, the founder and dev at Square Bears NFT, and today I'm just going to be talking about my implementation of the ERC721a smart contract. And here you could see it's on Etherscan. We launched last week. It's already live. Contract is verified, so you know it works. You could go on our Twitter and see all the raving reviews from our holders and how cheap gas was for them to mint. I'll also link those in the description below. Um, so yeah, if you don't know what this ERC721a is, it's created by Azuki, which was it's a number one NFT project right now on OpenSea. And what they did was they took the regular 721 from Open Zeppelin, and they found some extra baggage and some tweaks that they could do to make minting a little bit cheaper for people and save on gas, especially when you're minting multiple. So on their website, they have a little chart that shows how much you could save, and pretty much the Azuki ERC721a saves you when you do a batch mint, which means like you mint multiple. So if you mint one, it's not going to save you that many, but where it really shines is if you mint multiple. So if you mint five, for example, you're pretty much paying almost the same as if you minted one. And compared to if you didn't use it, you would have to spend so much more. So pretty much 5x. And this works for as many times, or not as many times, but as many you want to mint. So for example, for our project, we did a team mint of 200 a little before we launched our whitelist sale. And it came out to like $1 each NFT we minted. And then also you could see on our Twitter, and I'll post in the description below, that a lot of our holders were really happy when they minted, and they only paid like $23 for minting five, which came out to an average of like four each. But yeah, now I'll just show you the implementation of our smart contract. And I'll just go through it line by line really quick and just show you the implementation so you can learn how to do it yourself as well. So right here, we start calling our Solidity version. Then we have our three imports, the 721a Solidity file, the ownable Solidity file, and the Merkle proof, since we use the Merkle tree for our whitelist. We start the contract. We have our constants over here, just the max supply, the public mint amount, which is how many you can mint on public, how many you can mint on whitelist, the price of the public sale mint, and the price of the whitelist mint. And we got our URIs right here, the strings. Then we have our booleans that we toggled for different states of the contract. We have whitelist sale. So right after I deployed, I turned on the whitelist sale. And then when that was done, I turned it off and I turned on public sale. Then after that, a day later is when we revealed the contract, or not the contract, when we revealed the art on OpenSea. So that was another boolean where we came in here. And just to jump to the bottom real quick, here are all the toggle switches. So these are all external and by only owners. So you could call it if you understand how to call functions, it's right here. And if you are the owner, like I can call all these toggles when I want to toggle them. But let's go back to the code. So yeah, those are the booleans. Then we have the Merkle root bytes 32. Then we have two of these mappings. We have how many they minted on public and how many they minted on whitelist, just as two separate mappings, so we can trace and see how many they did. Constructor for the 721a, which just has the name and the token right there. Then this is a very important line. This modifier caller is user, and pretty much what it does is what it sounds like it does. Caller is user. It's checking if it's a user that's calling and not another smart contract. Because when another smart contract calls you, it can do things that you don't want it to do, right? You want to be called from a wallet address, and not a bot or a smart contract that maybe might hack you and maybe might mint like 500. And so that right there, that modifier, you could see I put it over here as well in the mint function and over here in the whitelist mint function, just to prevent any malpractice. All right, let's go through the mint function. So we have the four required statements right here. First one, we're checking if this boolean is true. If it is, we're good to continue. Second one, we are checking if we're past the max supply. So total supply is how many have been minted so far. Quantity is the parameter that was passed into this function. So let's say we are at 6664, and then we try to mint 10, which would be 6674. That is not less than this variable, which is this number, which is our total supply, which is 6666. That would cause an error, and we wouldn't go through with the mint function. So public sale is good. If that one is good as well, we move on to the next, and this is where we are using the mapping, which we declared over here, to see how many this person has minted already on the public sale. Message.sender is the person that is trying to mint. It's the person calling the function. So the mapping associated with that wallet address with the total public mint mapping plus how many they're trying. So let's say they minted 9 and they're trying to mint 10 more. That would be a total of 19 right over here. If 19 is less than max public mint, which is 10, this would work. It's not going to work if you have 19, so it would exit. So then we go to our last one. If you made it this far, now we are just checking if you sent enough money. Message.value is the amount of money that you're sending in. So let's say you send in like half an ETH, right? And then you want to mint 10. So you would do 10 times public sale price, which is about 1 ETH total. If you send half an ETH, it's not enough. It's going to break and you won't continue. And those are the 4 checks we do before we do the mint. And then if you made it to line 47, you're in the clear. Now, in the clear. This is when we increment our counter in the mapping. So message.sender now, if you're minting 10, we're going to put this mapping and we're going to say we're storing the fact that you minted 10 for the future, so you can never mint more. After that incrementation, then we just call the safe mint function, which is implemented in the Azuki contract, and they handle the rest. All right, cool. So that's the mint function. Now we go to the whitelist mint function, which is pretty much the same. The only difference is we are checking if they are on the whitelist, and how we do that is right here. We make the hash, and then with this line number 59, we call the verify function. And then, yeah, we have the same 2 lines from right here. Same 2 lines that are at the bottom of the mint function, which is incrementing the supply and calling the safe mint. And that's pretty much the meat of it, but I'll just go through a little bit more. Here's the team mint function, which I called right before launch just to secure the team of the 200 that we minted. Here is the getter for the base URI, the getter for the token URI, and then the getter of the wallet of. We have setters over here: set token URI, set placeholder URI, set Merkle root. We have the getters to get the Merkle root. We have the toggles that I already mentioned about, just to turn on pause, turn on the whitelist sale, turn on public sale, and then turn on reveal, and then the basic withdraw function. Yeah, that's about it. I hope that helped. If you want to show any support, you could give a like or go buy Square Bear off the floor on OpenSea. And feel free to reach out to me, especially if you're a holder. I'm happy to help you with any of your dev needs. Thank you so much. Have a good day.